Hello students, in the previous classes you have learned about the fundamentals of weaving and the preparation for warping, the draft and peg plans for weaving. Today we will investigate about various factors that control the weaving and also understand the calculations involved in making a fabric and also setting the loom for desired dimensions. A grey fabric consists of warp yarns, weft yarns and finishing materials. So, the weight of the fabric is influenced by the yarn weight used in the both the sides of the cloth and finishing materials such as sizing. When a fabric of a specified dimensions and weight are required, the weaver must set the loom and prepare the fabric as per the order. For this, the weight of the warp yarns and also weft yarns should be known. Depending on the weight of the sizing material is planned. Some waste is also made in weaving and during preparatory process, which cannot be ignored here. Besides these, there are various other factors which need consideration. So, let us understand these factors before we enter into original calculations. So, first of all, we will take the contraction of warp and weft. Generally, the cloth contains two sets of yarns which interlace with each other. Due to interlacement, the yarn bends slightly and thus the cloth produced is less than the length of the warp yarns. Even in the weft way, the width of the fabric will be less than the length of the weft yarns that are being taken. So, the amount of contraction will depend upon factors such as count of the yarn, that means how fine, how thick the yarn is, and then number of intersections, that is higher reed and picks will have more contraction, and then the nature of the weave. Plain weave, for example, if it is taken, it has a maximum number of interlacements. So, there will be higher contraction of warp and weft. Whereas, if you take the twill weave or the satin weave, the interlacements are very less, and so the contraction will be very less when compared to the plain weave. So, among all the weaves, I think plain weave is the maximum contraction. And then the elastic nature of the yarn. If it is elastic, what happens is while putting up the tension on the loom and also while weaving, and it will elongate, and then it will not show that exactly this much of length is required. But once the fabric comes to the consumer, and it will give problem that there will be lot of shrinkage, and so the elastic nature of the yarn should also be taken into consideration. And then tension applied during preparation and also the weaving. And then subsequent processing, what type of processing that is going to take up, like maybe it is bleached or it is dyed and all. So, we have to definitely look into these things, so that the fabric which we make should be suitable to the order given, or otherwise to the fabrics that are available in the market and which are going to be for a specific end use. The term used here to represent this contraction, that is the difference between the slash length to cloth length, is take up. So, it is represented in the form of percentage. So, for example, if cut length or tape length on the slasher is around 40 yards and the length of the woven cloth is around 38 yards, then the take up of warp is equal to 40 minus 38 divided by 40 multiplied by 100, you will get around 5%. Whenever you have this one, that is how much material is required, how much length of the material is required, how much of the width is required, and exactly when you remove the yarn from the cloth, how much it is, we have to take the length into consideration, and then we have to calculate it depending upon the dimensions of the fabric that you are going to take up. Regain is estimated from the warp length on a sample cloth. The general procedure is to cut a cloth to a particular dimension and withdraw the threads carefully without stretching it. The length of the yarn is then measured and the regain is calculated. For example, a cloth was cut to a length of 10 centimeters and the average length of the yarn withdrawn from it measures around 11 centimeters. Then the regain is 11 minus 10 divided by 10, that is the original length in the cloth, multiplied by 100, you will get 10%. That means that 100 meters of cloth requires around 110 meters of warp in the final material. Cut length or tape length is another term. This is the length of the warp required to weave a definite length of cloth. So, this tape length is equal to required length of the cloth plus uptake. So, we have given the the length that is there in the fabric and also the uptake, that means that contraction that is there. We are giving these two, then only it becomes the required length of the cloth multiplied by 100 plus percentage of regain of warp and divided by 100. So, tape length are marked on the warp during slashing. For example, we have to calculate the tape length for 20 yards of grey fabric whose regain of warp was found to be 6%. So, how you will calculate this one? The tape length is here now, we can calculate it. About the tape length is given is 20 multiplied by 100 plus 6, because it is the uptake or the 6 is there and which is divided by 100 again, and we will be getting around 21.2 yards or 21 yards 7 inches. Then width of the warp in reed and reed count. These are the two things that we should know. So, in case of grey cloth, the reed width can be found out by measuring the regain of weft. But in case of fabrics subjected to bleaching or dyeing, the fabric undergoes contraction as it passes through different finishing process. This cannot be ascertained by the method we just now discussed. So, experience based on the consideration of the factors discussed just now will guide us in such cases. So, we will see how we can calculate, or what is the formula for calculating the reed width. So, it can be calculated by taking the cloth width multiplied by 100 plus percentage of regain, which is again divided by 100. So, when we have ascertained the regain or percentage of contraction of weft, we shall have to find out the count of the reed to be used. This can easily be found out by reed count into reed width is equal to number of ends per inch in cloth multiplied by width of the cloth. Therefore, reed count can be taken from this, that is number of ends per inch in the cloth multiplied by width of the cloth and then divided by reed width. Then coming to the next calculation, that is loom pick. So, owing to the contraction of warp during weaving, picks per inch in the cloth are higher than the picks inserted per inch of the warp on the loom. Therefore, to ascertain the number of picks to be inserted per inch of warp on the loom, to get a certain number of picks in an inch of cloth, we have to proceed. Loom pick multiplied by tape length is equal to picks per inch in cloth multiplied by again length of cloth. Therefore, loom pick is equal to picks per inch in cloth multiplied by length of the cloth by tape length. Then we have to also look into the wastage that comes out, and we have to give the allowance for this wastage. This is an important factor, especially for costly yarn, because in such a case it is necessary to estimate the amount of the yarn required very accurately. The amount of waste will depend on the nature of the work, process gone through and other things. There are two kinds of waste, one is the visible waste and the other one is invisible waste. And visible waste, in case of warp, a quantity of waste is made in winding, and also this waste is derived from cob bottoms, spoiled cobs, bobbins or hanks, piecing waste. Now, the amount of waste will be more in case of winding from hanks. On high speed winding machines, the percentage of waste is very low, and the slasher may contain some waste, but the loom waste is almost negligible. Allowance for waste to be made for grey warp, example 30's count on ring bobbins is about 3 to 5%. In case of colored warp made from hanks, the allowance for waste to be made should be about around 5 to 7%, just because it may not contain one color, it may contain different colors, and so the wastage may go high to 5 to 7%. In case of weft supplied in the form of ring bobbins or mule corps, which can be directly used on shuttle, the percentage of waste will be very low. Then coming to the invisible waste. Invisible waste refers to the loss of moisture in the yarn before weaving. So, loss of weight during winding and warping and also processing such as bleaching and dyeing should also be taken into consideration, and it comes under the invisible waste. So, this will not be seen actually. The moisture may be, the weight of the warp and weft may be more before weaving, but when you leave it for some time, the moisture is left from this one, and also during weaving and during all the other processing and all, and it will be losing the weight of the fabric, and even the thicker yarns become thinner after processing. And so, this is the invisible waste, it will not show at all anywhere, and so this should be considered and allowance should be given to that. And then coming to the allowances for selvedges. We have a selvage, the fabric has selvedges on both the sides, and it runs along the lengthwise grain of the fabric. And so, if the selvage is smaller one like 1/4 inch, like in dress materials we do not require very broader selvage, but we need a smaller selvage, because the selvage is very important, otherwise the fabric tears. And so, when we take this smaller one, there is no need for having more number of yarns here. Only thing is that 1/4 inch, in case of reed, when you are placing one yarn there, for 1/4 inch this side and that side we will be placing 2 yarns, that is all. It will be like the other body of the other fabric only. And in case of tape and other special selvedges, we need to give allowances for these things, and particularly we should see how much is the width of that particular tape, and then allowances have to be given accordingly. And then allowances for size of yarns. So, if the size of the yarn, we know that you have learned also in previous chapters how the yarn sizes are being measured. We have for filamentous yarns and also for yarns like spun yarns like cotton. Cotton has a yarn numbering, whereas filaments have a direct kind of measuring the size like denier or tex. But in case of cotton, it is going to be called as the yarn number. Maybe if we say that 20s, 30s, 40s, 60s like that. And so, that means that 1 pound of cotton, if it is drawn to 840 yards, then we call it as a 1 yarn count. 20 yarn count, 20s means 20 yarn count, show that 1 lb cotton has been drawn to 20 times 840, that is 840 into 20 times. In the same way, 60 yarn count show that the yarn is being drawn 840 into 60 times. So, like that we have the yarn size, and so the allowance also should be given to these things. And then allowances for counts in bleached and also dyed goods. Allowance definitely should be given, because we just now talked about it. That means during the bleaching, during sizing will be removed, and also scouring, that means that all the impurities that are present in the fabric will be removed during this one, and dyeing and other things, so that the weight of the fabric comes down, because the lint and other things will be removed while undergoing this processing. And so, we have to definitely give allowance for these things. And then coming to the finally the warp and weft calculations. In calculations of a cotton cloth, the formulas given will be found useful for determining various particulars required in practice. So, they have all been derived from the fundamental formulas. So, the count here is the number of hanks per pound, that is just now talked about. One hank is 840 yards. And then coming to the first warp, how we are going to calculate. Here we have to know the total number of ends in a cloth, that is the number of ends per inch in a cloth. If it is multiplied by cloth width plus extra ends for selvage, you will be able to get the total number of ends in cloth. Or we can also say in this way, number of ends per inch in reed multiplied by width of the warp in reed plus extra ends for selvedges. Then coming to the length of warp yarn in yards in cloth, it will be tape length in yards and which is multiplied by number of ends, and then total length of warp yarn in hanks, and this can be calculated by taking total number of ends which is multiplied by tape length in yards and which is divided by again 840. The weight of warp yarn in pounds can be calculated by taking the total length of warp yarns in hanks which is multiplied by the count of the yarn, and then the count of the warp yarn can be calculated by taking the total length of warp yarn in hanks which is divided by weight of warp in pounds, that is equal to total number of ends multiplied by tape length in yards and again divided by 840 which is multiplied by weight of warp in pounds. So, by cross multiplication of all these things we get the formulas such as tape length in yards, for example, count of warp yarn which is multiplied with the weight of warp in pounds and also multiplied by 840 and divided by total number of ends. Length of cloth in yards, it can be calculated by taking the count of warp yarn multiplied by weight of warp in pounds multiplied again by 840 minus uptake divided by total number of ends. And because cloth length is equal to tape length minus uptake. And then coming to the total number of ends. So, the count of warp yarn, then it should be multiplied by weight of the warp in pounds and again multiplied by 840 and then it should be divided by the tape length in yards. So, these are the warp calculations that people in the industry as well as the weaver do in order to ascertain how much warp that is required for weaving the cloth of desirable dimensions. And then coming to the weft calculations. And so, it will be little bit similar, but when we take the warp here we will not be able to take the warp, but we will take the weft and the how much width and other things. So, to calculate the total length of weft in yards, then we take the total number of picks, this is multiplied by length of weft in reed in yards, that is equal to length of the cloth in yards multiplied by picks per inch in cloth, it is again multiplied by reed width in inches. So, picks means it is only weft. Okay, warp yarns sometimes are called ends and weft yarns are called as picks, and so here pick means it is a weft yarn. And total length of weft in hanks, then it is can be calculated by length of the cloth in yards, it is multiplied by picks per inch in a cloth and then again multiplied by reed width in inches and divided by 840. And then weight of the weft in pounds can be calculated by total length of weft in hanks and it is divided by count of weft. And then coming to the count of weft, we have to take the total length of weft in hanks which is divided by weight of weft in pounds. And then we have the cover, how much cover it is going to do on the surface of the fabric. So, warp cover, weft cover and cloth cover, these are the three important calculations that we have to do. So, warp cover factor, that is called as warp cover factor, and it is ends per inch by root of warp count. By this we can calculate the warp cover factor, and weft cover factor can be calculated by taking the picks per inch divided by root of weft count. Then cloth cover factor can be calculated by taking both the warp cover factor plus weft cover factor minus warp cover factor multiplied by weft cover factor by 28. 28 is going to be a constant. Practically, when we want to do the warping, we cannot take that such long warp yarns and other things. So, section by section we can take the warp yarns which are required for that particular small length. Like in handlooms, we may get 1 saree or 4 sarees or 8 sarees. In that case, it is warping is done by section. So, it is called as section warping. And then we have another term called peg warping. That means that a smaller tablets like that is taken, and the warp yarns are wound on 2 nails on the other side, and then we can insert the weft yarns through. In case of wall hangings and other kind of things, that they will be producing on this kind of small tablet looms. If you want to make your own, there is a way. For example, you have slates which are broken at home, those things you can take, and because it is a frame on all four sides. And so, on the frame we can just put up the small nails on either side, and take the longer side of the slate for warp yarns, and shorter side as a weft yarn, that is the width and this is the length. So, we are also showing you one of the illustrations here. You see that the warp yarn or any thread you like, you just take and start from one one of the edges to the till the next one, and then bring it up down, and then take it up again the warp yarn, and thus you can complete putting the yarn over the top nails and the bottom nails. Thus, when you tie up at one point, then your warp is ready. Then if you want to insert weft, you want to insert only say a thread, or if you want to insert a peg or a small a kind of ribbon, or even a cloth which is torn, that you can do it by just putting it over a cardboard, small cardboard, bind it around, and then try to take it one after the other, the plane weave, one by one, and down, take it up and then go down one by one. So, you can do it like that, or if you want to go for a kind of twill, then you go over 2, under 1, over 2, under 1, or otherwise under 1, over 2, or under 2, over 1. Like this you can do it, or even in case of satin weave you can try out here, because it is very easy to do it. So, you take 3 yarn, the yarn or the tape over 3 yarns, warp yarns, and then go down on the 4th one. Like that, how much you have, how you have learned the drafting and also the peg plans and all those things. Taking all these things into consideration, you try to come up with your own samples. You can show it to others, you can even scan it and then put it on the web, so that everybody can see it and we can appreciate you. So, students, you have seen the calculations that are being involved in making the cloth, and so do not think that it is very easy to get the cloth into the market, and the weaver and also the industry and people work very hard in order to bring out a fabric which we like, because sometimes when we want to produce a fabric of 40 inches wide, and then they may have to weave around 42 or 44, depending upon what are all the factors that we have discussed here. Depending upon that, they will be either taking it 42 inches or 44 inches, and in subsequent processing, weaving and processing, the fabric comes to 40, and thus we are enjoying the fabrics. I am sure that you have enjoyed these calculations. Thank you.